All right, welcome everybody to CivicTechYYC here for November 12th, 2024. Tonight we have improved weather forecasting through better data and generative AI. And we've got Craig MacRitchie, who's the co-founder of Erode AI, which is a climate startup delivering weather forecasts through generative AI, moving beyond traditional physics-based models. Just a land acknowledgement here. CivicTechYYC is an organization that resides on the traditional territories of the peoples of the Treaty 7 region in southern Alberta, which includes the Blackfoot First Nation tribes of the Tzitzika, the Bikini, the Kainai, Stoney Nakoda First Nations tribes of the Chiniki, Bearspaw, Wesley, and Tsuut'ina First Nation. And this is also homeland to the historic Northwest Métis and the Métis Nations of Alberta. CivicTech is a technology movement for public good. We use data to design and address challenges citizens and governments are facing, helping citizens and governments work together to use technology for data and design, pursuing opportunities for greater citizen engagement and more effective services, growing public engagement, and enhancing digital services in ways that are more inclusive, responsive, innovative, open, and citizen-centered. CivicTech is a global movement, and it's expanded dramatically over the last 15 years with the help of organizations like Code for All. In the US, cities like Chicago, Boston, and New York City have led the movement, as well as organizations such as Code for America, the US Digital Service, and 18F. There are civic tech organizations in many locations around Canada, which are all listed on the Code for Canada website, and also government agencies like the Canadian Digital Service. CivicTechYYC was launched in 2017, bringing together people who had an interest in improving their community through technology, and it was done leveraging the support of the City of Calgary and the Rainforest Alberta Network. The driving force has been to break down the barriers between sector silos and create a space for collaboration, addressing the challenges and opportunities that citizens and government are facing. And CivicTech here sits within the center of that City of Calgary work with open data government, and it also connects to citizens, communities, social innovation, as well as the technology sector, regional partnerships, and also includes entrepreneurs, startups, and education. Some of our major projects have included the BudLib Library Database Management Project. We've done experiments with blockchain, not crypto, just using blockchain as a technology. And Alice Lamb started up a volunteer app called Volley through CivicTech a number of years ago. We are also involved with civic user testing groups. These are grassroots groups that facilitate better and more inclusive, accessible usability and testing that engages residents in the creation of technology that's meant to serve them. Together with Calgary UX, we at CivicTech started an organization called Inclusity Calgary. It's a team of technologists, designers, public employees, community organizers, and entrepreneurs and policy analysts, along with other engaged citizens. We share a vision that Calgary can be a more accessible city for all, and we design, run, and manage testing sessions with an inclusive and representative group of Calgarians to improve the usability of products, processes, services, teams in public, private, and not-for-profit sectors. We're proudly supported by the Calgary Foundation, who provided us our funding to get started there. We're also connected with a number of other partner groups and organizations, including Code for Canada, Calgary UX, Data for Good, the YYC Data Society, Platform Calgary, Immigrant Techies Alberta, the Test Tribes that also did some user testing, as well as the OS Geo meetup, which is the open source geoscopal foundation in its local chapter. CivicTechYYC, you can find us on our meetup page. We've got our website, X formerly Twitter. We've got Instagram, Threads added recently, as well as LinkedIn and Facebook to be able to follow us for updates. That's all I've got for my formal start here, and I'll hand it off to Craig to get started with his presentation this evening.
Yeah, thanks, Ross. And thank you to everyone at CivicTechYYC for joining us today for our presentation. Let me know when you can see the screen.
Looking good?
Looking good? Okay, sounds good. So, yeah, I'm here today to talk about Erode AI. We do custom AI weather forecasting solutions. So the company founders are both myself and Dr. Cody Kupferschmidt. So my name is Craig MacRitchie. I'm the founder and CTO. Um, I used to work at Dillon Consulting doing water resources engineering. And after doing that for a few years, I ended up getting interested in software development and attended SATE doing their object-oriented fast track program back in 2016, 2017. I worked at a number of different companies during my software career and eventually ended up making the leap to do Erode AI full time back in June 2023 with Cody. So we've been at it doing it full time for about a year and a half now almost. So Cody, he went to U of A for his water resources masters, and then he was in Edmonton for a few years, and then ended up moving back to Ontario to do his PhD in forecasting using generative AI, and then he currently resides in PEI right now. But we try to get him out to Calgary as often as we can. So, why focus on weather? I'd like to ask the everyone a few questions, and feel free to raise your hand if this applies to you. So, have you checked the weather forecast in the past few days? So maybe a few people. Okay. Has there ever been a time when the weather forecast was wrong? Sure, we've all experienced that a few times. Has there ever been a time where a wrong forecast ruined your plans? So, maybe you were planning on going skiing or doing an outdoor activity and then rain unexpectedly came, or you're planning a weekend trip, 4 or 5 days out, and then that got canceled. So, yeah, yeah, we got a few hands. And then finally, um, has a wrong forecast ever put your life in danger, caused damage to your belongings, or financially impacted you or your business? Yeah, so Michael, and then yeah, maybe some others. So yeah, it's a big issue for sure. So unpredictable weather costs companies billions of dollars. So annual global insured losses due to natural disasters back in 2023 was $108 billion USD. And that's just insured losses. Estimates were around $280 billion. So that means there's a huge gap for you know, um, in losses that were not insured. Whether that's people not wanting to insure their assets because they don't think that it's worth insuring, or maybe the insurance providers don't provide insurance for what they want, or maybe that there's just they don't think that it's worth insuring because you can't. The current forecasts are so far out that you can't accurately provide information to decide whether or not to insure an asset. In the US, crop losses due to extreme weather was $22 billion back in 2023. So, Alberta has a massive agricultural sector and is also, heavily influenced by weather for not only um, crop growth, but also, crop insurance is huge. And, excuse me, the investment gap for climate resilient utilities in the US is around $500 billion dollars. So it would cost around $500 billion dollars to make, the utilities completely resilient, which is an extremely high cost. Let's move forward. So it's not just those industries. Those are just a few industries. Um, There are a ton of other industries. A few clients that we've worked with have mentioned staffing is just an issue based off of weather. Municipalities have weather issues. Departments involved in logistics and operations, retail and clothing, transportation, construction is a major industry that relies on weather. And then, emergency response is also huge. So, Gartner is an American technological research and consulting firm based in Stamford, Connecticut, that conducts research on technology. And they found during a survey that 54% of CEOs say their businesses are affected by changing weather patterns, at least moderately. Over half, 51%, acknowledge changing weather patterns are causing them to plan changes to the way they operate or have already done so. So if you're a business owner and you aren't thinking about weather, then you're in the minority. And those numbers are only have been increasing every year. Impacts to Calgary and Alberta. So just in 2024, there have been some major impacts from weather. Let's take a look at a few. So there's that Calgary hailstorm that happened. I know a number of friends. I'm sure many of you have either been affected or know people who have been affected by that hailstorm. It caused tons of damage, both to you know real estate, vehicles, and other assets. There was that massive Jasper wildfire that can back in the summer. And then there's also been drought, and this is all just in 2024. Um, there have been other massive weather events that have happened in the past. You know, the flood in 2013 is what brought me out to Calgary, and has been a huge task for both cities and municipalities to help mitigate and manage flooding in a lot of the regions in Calgary. So you might say, what's wrong with the forecast today? Like, there's lots of forecast providers. Why do they keep getting it wrong? And the big thing about a lot of the traditional forecasts is that they are traditionally physics-based models. So, uh, additionally, along with that, they're global models. So the thing about that is when you have physics-based global models, all parameters are weighted equally. And so, one parameter on one side of the world is equally weighted to another parameter on the other side of the world. In order for the physics simulations to add up, you can't have an instance where there's physical properties that don't line up. For any of you who have worked in computational flow dynamics or worked, with fluid dynamics, there's uh, there's all sorts of equations like the Navier-Stokes equation. There's the ideal gas law. There's the what was the other one? It was the eddy simulation, the large eddy simulation. So these are all um, calculations that are being done to make all of these physical based forecasts balance on a global scale, and they're quite resource intensive, but moreover, the parameters have to all they all have to um, they're all equally weighted. You may see some forecasts where some government forecasts where a certain area is more heavily weighted. So, for example, you might just see, okay, these are just forecasts for North America, or forecasts for Europe. And the reason why they do that is because they're able to kind of get a little bit more accurate forecasts in that area, but then the rest of the world, the parameters slip a bit, and maybe they aren't as accurate. So that's why you might see some government-based forecasts where they're not global, but they're kind of in a more a more defined area. Still a large area, but a little bit more defined. And as I mentioned before, with everything having to balance out, the uh, computational requirements and the high operational costs, and the bad spatial resolution really delays forecasts. So some forecasts they might be on a 0.25 or zero point 0.5 degree grid because running any higher would just drive up operational costs and then also compute costs. So you're really kind of limited by um, the both the hardware and the limits of physical based forecasts. Um, let's move forward. I also wanted to mention, uh, if you're looking to forecast data in an area where there's unique geophysical features like mountains or valleys, that can also cause some discrepancies in the weather forecasting because the grid might include like mountains or not necessarily in Alberta, but if it's by a large body of water, it can really throw off the forecasts. And with those less fine grained forecasts, you can get a wide range of parameters and forecasts there. So the question becomes, can artificial intelligence help forecasting? And the answer is yes, absolutely. AI weather in the news. This is fairly new, but we can see the route that occurred from Hurricane Beryl. So the blue line here is the current forecast model using physical-based approaches. So you can see it kind of looks like it heads, more down south into Mexico, but using AI, the forecast predicted up through Texas, over to the Northeast United States, and in fact, the actual path of Beryl was more closely along that generated AI path. So absolutely, we can definitely see improvements in weather using generative AI. What if creating AI weather forecasts was easy enough for anyone to do it? So, um, you know, we're trying to build the custom GPT of weather forecasting. So a lot of the times people want to have specific parameters and specific horizons for what they're looking for. So the way that it works is you define what the parameters you want, what the horizon is that you want, and then we help build out those forecasts. So we've been working with some of the biggest energy companies in North America to forecast weather and weather-derived outcomes. Um, we have seen a reduction in the root mean square error, so 22.2% reduction, which, it might not seem, it's hard to determine for a lot of people if that's beneficial because, for a lot of us, we just care about, can I walk my dog today or can I go out well, I need a raincoat today. But for some of these companies and um, municipalities that really rely on very accurate weather forecasts, 22.2% is a huge reduction and shows some massive improvement in margins. So how does our technology work? So here's we have a bunch of technologies we can leverage, but here's one of our use cases, which is I think it's a good visualization of what's going on. So on the left here, you can see there's a global model and it has a resolution of about 0.25 degrees. So 0.25 degrees, depending on the latitude and longitude, it can change quite a bit, but it's sometimes around 45 kilometers. It's quite large. Uh, and this kind of ties back to what I was talking about before with the unique geophysical features where, 45 kilometers, that's a huge area. Um, and there can be microclimates within 45 kilometers. There can be all sorts of different features and forecast like forecasts that happen within that grid. So what we do is we can use hyperlocal downscaling to downscale the forecast down to 5 kilometers to fine tune the historical data to help have the best predictions possible. So the results come in three easy steps. So I kind of mentioned it before, but I wanted to touch back again. Anything that's in, we can predict weather, but we can also predict anything that's impacted by weather or their weather dependent or their weather derived outcomes. So, you know, Calgarians love ice cream. You might want to know what ice cream sales are going to look like in December or November, when most of the country is not selling ice cream. Calgarians are out there eating ice cream. I know I'm guilty of that. Um, Bike rentals, ski conditions, and for energy companies finding peaks. For municipalities, they might be interested in what are the chances of flooding happening in the next week or so that we can mitigate flooding possibilities. So, there are numerous solutions that we can provide. The results happen in three steps. So first, there's the data acquisition and setup. So you tell us what you want and what you want to predict and the forecast horizons and the parameters you want. Next, we make a model and we train it on historical data, and we do various machine learning and AI operations to help with downscaling and set up the predictions that you want. And then finally, we do the operational forecasts and verifications. So whenever you check our website, we'll have the latest forecasts and we'll tell you how we're doing. So we want to be, transparent about how well our forecasts are doing compared to, what actually happened, because it seems like a number of our clients are facing sort of a similar issue where, yes, you're providing forecasts, but how well are they performing to what actually happened? Or, maybe if the client has actual weather station data, they can compare their forecast to what actually happened at that station. So we want to be transparent and say and show our clients how well we're actually doing. Um, and on top of that, it can be difficult for some of our clients to kind of view some of those past forecasts. It takes time, it takes money and resources to do perform those analysis. So we want to add that extra layer of verification so that our clients can see how well we're doing, and also verify that what we're providing them is providing value. So here's another example of forecasting weather impacted outcomes. So one of our clients runs a wind farm, and they want to find out what the energy forecast is. So for a lot of these energy forecasters, they don't necessarily care too much about what the actual weather is. They want to know what the energy is. So by kind of abstracting that layer, building the energy model, and then feeding the wind speed into that, we're able to derive these, create these weather-derived outcomes. So in this case, an energy forecast. Not sure how many people here have worked with wind turbines or um, worked with wind energy curves, but there's kind of like a cut once the wind speed in some of these turbines reaches a peak. They'll end up actually shutting down or operating at less at lower producing less power, just to kind of curtail and prevent damage to the turbine. So you can kind of see here that it kind of peaks out at 200 megawatts. And the reason why this is helpful is because a number of energy traders or people working in the energy sector, they want to know the energy that's created. They they want to know the derived outcome. They don't necessarily want to know what the weather is. That's just an extra step for them to reach the the solution that they're trying to achieve. So this is kind of a preview of some of the features that we're working on in the next year. We're really excited about this piece. So we want to make it easy enough for anyone to use. So um, un we have spoken with a number of people who are very technical, and then there are some people who may not be as technical and involved in the weather space. And what we want to do is make it easy for anyone, regardless of background, to be able to um, find the weather forecast that they want. So by using some LLMs, will allow a user to input their problem that they want to solve, and then behind the scenes we end up configuring the parameters using the by using this trained LLM. And then also, if the client decides that they want to upload some additional data to help with their decision making, they can do so, and then they can find the forecast that they want without having to configure any technical details. So in this example here, we have, Calgary snow removal. I want to accurately predict snowfall this week in Calgary so I can staff my snow removal business. So, we're really excited about that, and that's a feature that we are currently working on right now. How much better can we do? So a big question that comes up all the time is how well are you guys doing, and how well do you do compared to others? So here is some data that we collected from one of our clients. Can't share that who the client is right now at the moment, but as you can see, we're performing better in terms of root mean square error than our competitors right now. And the reason Now, I don't want to say the definitive reason, but likely the reason why we're doing better is because the competitors that were providing these forecasts were using either physics-based models that were, global, or they were using a general purpose um, AI forecast. So there are a few out there that we're aware of, and they're kind of what they want to do is they want to have the best general purpose model. Um, Available to everyone. But the downside in that is that these massive companies like Google, IBM, NVIDIA, they're finding that they can create some of these general purpose models quite well, and they have a way bigger staff and budget than some of these other companies trying to compete in that area. So we found that where we provide unique value is that we hyper focus our forecast for a specific location. And, large companies like NVIDIA, Google, IBM, they don't really want to get into that space as much. So we kind of provide a unique solution that we think gives us an edge over our competitors.
Just a question in the chat there,
Yeah, sure.
asking what are the axis values on the Y there?
Yeah, so that's like yeah, I noticed that before. So that is it was supposed to be out of like um what is it, like 100%. So these this yeah, we don't I didn't include it. But I think the big takeaway is that we're showing improvements. Um, I can get it. Who's ever interested in that, I can get those values for you, and I can send them. Or if there's an easy way to like send them in the like meetup chat, I can always do that later once I've collected those. But yeah, good question. And another thing to note here is that for this client, they wanted a sort of a 4 to 5 day uh, forecast horizon. So you can see there's kind of like a dip here where we reduced the root mean square quite a bit and achieved what we wanted to achieve. The competitors also were able to do that, but not at the level that we were. So that's a great question, and I will try and send that back to the meetup chat. Okay, let's move on to empowering civic tech. So, how can our technology play a role in the civic tech movement? So, we can help by leveraging public or local data sets to improve local forecasts, make improvements to public safety through early warning systems and being transparent about forecasting approaches. We can facilitate integration of renewable electricity generation, including decentralized or household wind and solar installations. And I would love to hear from everyone who has some ideas. Like, what are your ideas on how our platform can be leveraged? We've had cold outreaches from a number of people in different industries who have found solutions that we hadn't even thought about, but we'd love to hear about it. So my name's Craig MacRitchie. I will be at the Platform Innovation Week in a couple of weeks. So feel free to come by, stop by the stall, say hi, and yeah, thanks everyone for attending the presentation. I'd love to hear any questions or any comments that anyone has.
Yeah, we can open it up to questions or if people have any ideas of how it would be used. Usually the way I do this is we have kind of a formal Q&A that would be on the recording. And then once that fizzles out, we usually just stop the recording and then go into more of a casual discussion Q&A. So first set of questions there. Jonas, you've got your hand up.
Yeah, great. Thanks. Thanks for the presentation. It was very interesting. Like, how does the forecasting work from a macro versus micro level? Like, where are the boundaries? In your example, you had Calgary for the next week for snow, so that's already pretty good. I'm more thinking about it like you spoke about Alberta and farming, right? So hail is obviously a very big topic here. It applies to the civic level as well when you just look at the northwest, northeast hailstorm from earlier this year.
Yeah.
To what extent would these events be predictable? Because other than saying like, everyone can say that there's hail in Olds, but
Yeah.
like the question is who else? Not who else, where else is it going to go?
Yeah, good question. So we kind of work on 5 kilometer. We scale down to about 5 kilometer accuracy right now. And wherever there is, like you can set the asset wherever you want, but we downscale it to about 5 kilometer accuracy. Um, as for the different like locations, we 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 know that there's a lot of different parameters that go into the forecasts that like for example, there are a few users who they want to have, they want to know what's it going to look like in a week from now. We don't necessarily care what's going to happen like today or tomorrow. We're planning weeks out, so we can set those forecast horizons if that's what you want during model training, and then further tune it with like weather. If you have like a weather station or ground truth data, we can feed those back into the model to do fine tuning.
Mhm.
So you were wondering about how large the grids are that we have the forecast for, or
Yeah, more, well, let me rephrase the question. I'm kind of more like looking at so the intensity level as well, right? There's a difference between small pea-sized hail and like baseball-sized hail. Like,
ah,
would your model go as far as like being able to distinguish between the two in the prediction?
gotcha. Yeah, so for our forecast, we have like confidence intervals to say how because I kind of mentioned it earlier with the butterfly effect, but there's there are so many different variables to balance that we can't say with absolute confidence that we're going to follow this single line. It's going to be there's our chances of it changing a little bit. But as for how far we go out, right now we can confidently go out about 10 to 14 days. We can go further, but the accuracy kind of drops a bit.
Right.
And then we're working on like a paleoclimatology piece where we can predict it's not so much weather forecasting, but adjusting distribution curves for, years out. So for example, like an El Nino year or La Nina year, those ones we can't say, in 2029 on August 30th, it's going to be X. We can say, okay, it looks like there's going to be more rain than usual in this area. And we're kind of fine tuning that. We're kind of working on that now, but it isn't quite ready for production. But yeah, to answer your question, it's about 10 to 14 days right now. And then we're working on using like actual ground truth data to kind of extend that forecast out further. Because yeah, we're predicting tails, which can be like quite difficult sometimes.
Okay, awesome. So like forecasting like how much snow is going to fall over the entire winter, not really the best use case. The like short-term range, like you said, 14 days, that's where your accuracy is really peaking compared to the other models around this, right? And then coming back a little bit, like macro versus micro, right? When we have Calgary forecasts, and I look at that, right, and it says like, well, chance of thunder showers 20, 30%. Right? To me, that coming back to the old example, that means like chances are high Calgary or like at least some parts in Calgary are not going to see anything because it's very unlikely to hit there, right? So
Yeah.
can you then really like from when you say 5 kilometers down, like predict similar to for the quote unquote pathway that you predicted for obviously the hurricane, which was a big weather system, that once it was there, like I think it becomes more a known entity, like to predict its path moving forward. But those thunder showers, right, they develop over the foothills and then really grow and move as they come into the prairies and start unloading heavily, right? So is your model actually really capable to kind of predict multiple pathways based on weather station data and can say like, okay, we're looking at this stream here in the Alberta map, like again, just between Airdrie and Red Deer, that is very likely to be hit with a hailstorm, but a little bit further south, probably not.
Yeah, so are you talking about kind of predicting the path that it will go?
Yeah, yeah.
Um,
I'm
y-
thinking farmer scenario, right? Like that is a farmer and hail. Like that is a the extremely big use case that I'm slightly familiar with too. So I'm kind of curious to what is actually doable that way.
yeah, so we kind of do more like point data. The lines are something that we're working on to kind of predict, okay, what's it going to look, what's the direction of like a hurricane or a storm. But more of our data is just point with like a resolution of 5 kilometers. So what we found with a couple of clients is they might want to set up a number of points, almost kind of creating a line, but kind of predicting the exact like direction and path is something that's a little bit it's definitely a little bit tricky. And hail is something that's quite it's proven a little bit tricky to predict as well. Uh,
Mhm.
but yeah, most of our mostly the way we do it right now is like selecting a point and then like kind of providing like a resolution.
Okay, got it. Thank you.
And yeah, and I know you mentioned it earlier. You said like midterm forecasting. So yeah, midterm forecasting is like something we're working on. It's maybe one of our, like months out. It's there is room for improvement, but our our big features right now are kind of like 0 to 14 days, and then setting those horizons that you want to see.
Mhm.
Yeah.
Very cool. No,
Yeah.
thanks.
Thanks for the question.
It's just one of those pieces as well, whereas like the longer you develop the software and refine your modeling and forecasting, you'll be able to kind of expand potentially into those avenues.
Yeah, the models take quite a bit of time to train, and they're also quite resource intensive as well. But then, kind of once we have a model put together for an asset, we can fine tune it and provide even more value and more accurate weather forecasting, and try and extend those forecasts out further than the traditional, 10 foot to 14 days.
So you're not just refining the model, like your general forecasting model, you're talking about even the specific model. So you're creating a specific model for each customer and each asset. And as you track and manage that longer, you're then getting more accuracy and more detailed data over time.
Yeah, so for each asset, whatever the parameter and the forecast horizon is, we'll train that model, and then if there's further data to supplement it from historic or ground truth data from like weather stations, we can provide that to provide more value and better forecasting.
Okay, very cool.
Yeah.
We've got a question in chat there as well, saying, when do you think this would be ready for somebody to download on their phone or potentially anyone to use?
Interesting. Yeah, it's a good question. So right now we're a B2B company, so we're selling to businesses because um, we do more fine tuning for specific assets. A number of competitors out there are providing more general purpose solutions. And while our general purpose forecasts are good, we're not trying to be the best because, some of these bigger companies like NVIDIA, Google, IBM, who have the resource capacity to provide these general purpose ones forecasts, they're the ones who are going to be providing the forecast, to customers. So to answer your question, to have it available to the public, we don't have it on our horizon for this next little bit here, but we do eventually want to have something available so that anyone can use it. But as far as having it available for customers, we do have customers on the platform right now. It's just not it's not available for like public use, just for anyone to just go to access it right now. But it is something that we want to eventually get to get to, but just not at the moment.
How is it on the phone access side of things? So I'm thinking about like, say you're a company that manages operation, you have employees on site at some sort of, say, industrial or production or retail operation.
Yep.
Is there potential for either a web access or an app for those employees on site to be able to also receive that same information that's coming through your system?
Yeah, yeah. So we do have like our website is it's UI responsive, so you can view it on your phone. Maybe I misunderstood the question. I think maybe the question was when can the general public access it? So yeah, I
I'm
mean
just taking multiple
yeah,
sides from that
yeah,
question and thinking and extrapolating because there's kind of both pieces there.
yeah. The yeah, so yeah, to anyone who, like clients right now, they can access it on their phone. We are kind of working on the phone UI user interface, but that will probably come shortly in the new year when we kind of focus more on the mobile version of it.
Cool. Uh, Got another question in chat here. A person says that they're curious how this generative AI is different from the traditional ML model training and projections.
Yeah, so The ML team is using, I can't talk a whole lot about the specific technologies, but they're using, what is it? Um, I'm not part of the ML team, but they're using graphs and I don't know if it's tensors, but they are using a number of like newer ML techniques to like develop their product. So um, to kind of answer your question, it's not a great answer, but we're not using like the physics-based approaches. We're using some of the machine learning models to solve some of these solutions, and then loading it onto the platform in a way that clients can use it.
Uh,
I could give a better answer, but yeah, we're not using LLMs to figure this out. We're actually like building these in-house. So I know there's a lot of companies who they might say, we're an AI company, but they're calling, ChatGPT or Claude or whatever. And yeah, we're actually building these and training these in-house.
Yeah, there's a lot of companies that will take like the off-the-shelf stock backend from one of these companies and they'll just throw their application around it and that'll be the core and they'll have their own custom wrapper or they'll throw their own prompts onto it, whereas you're genuinely developing your own models and your own systems. And to your point, like there's that massive resource requirement and compute requirement to really build into that. I guess there's a parallel question that I have. How is development of the app gone with kind of the development in AI since it has gotten popular on the mainstream on the Chat GPT side of things? How has your journey been there, and what sort of successes and challenges have you had along the way so far?
Yeah, I mean, it's been definitely a lot of work. Um, our team has been taking a look at kind of newer, has kind of been like on the forefront of, new forecasts will come out, like Google's come out with like, new forecasts, and then new techniques have come out, and our team has kind of stayed on top of that in order to stay competitive. I think what also makes things quite difficult too is the large cost associated with compute power. So, some training some of these models, I mean, they can cost tens of thousands, hundreds of thousands of dollars. So, we've been pretty fortunate that we've been selected in part of the Google startup program. So we've been able to secure some compute credits in order to train these models. But that's definitely something that's helped us a lot. But it can be difficult staying at the forefront of a lot of these new emerging technologies, especially in the AI space, because it is moving so quickly. And there is always, something new coming out, and in order to stay competitive and to provide the best features and product for our clients, we have to be on top of that and be prepared to scrap something that we maybe worked on for quite a while that ends up being not as accurate as some of these newer techniques. So yeah, it's great question. It's been a grind, but it's also been very rewarding, and it's always good to see that when our forecasts have outperformed other either government models or competitors. So yeah, it's been a lot of fun, but also a lot of work.
That's great. Have you also felt, like, has there been an increase in compute power then? Because I know I've heard a lot about NVIDIA's compute power increasing. It sounds like you say you're using Google as your backend, so I imagine you're using compute credits and using their cloud systems for that. Have you noticed an increase in capacity on your side of things as that technology has advanced?
There has been, yeah, I mean, we have noticed that it costs quite a lot for a lot of the initializations for sure. But then there's also been, some of these languages coming out that directly interface with the GPUs that allow for kind of more efficient um, crunching of numbers and training of models. So it hasn't been huge, but we have noticed, if we didn't have some of those compute credits, some of the things that we want to achieve would maybe not be possible or would take an extremely long time.
I'm thinking more along the data side of things that you're feeding into these models. What sorts of data sources and data systems could potential interested companies or clients either bring to the table or look at sourcing and augmenting into their current operations that would provide greater benefit for you to be able to provide better service with those models?
Yeah, good question. I think the biggest thing that some of our customers can provide is ground truth data from like they have weather stations, because some of these physics-based models, just the way that the calculations and um the they might, at some of these stations, the weather that is collected, it might not physically be possible to predict those using some of the limitations of physics-based approaches. So by providing actual ground truth data, that is probably some of the most important data that can be passed back for like fine tuning. Um, we can help adjust like the forecast horizons and all the parameters that you want to see, but to really get that fine tune and really add kind of that extra layer of accuracy, like those are quite those can be really helpful.
Would adding more ground stations increase the resolution that you're working in? So you say right now you have like a 5 kilometer range. If there was more ground stations, say inside of a smaller facility and trying to forecast, like I'm thinking about if you have large buildings kind of affecting other areas of wind tunnels and that sort of thing, could having more of those stations improve that detail and accuracy of the model?
Yeah, a lot of the weather stations are for the points where the assets are, but leveraging some of those stations can definitely help with sort of the model training and then fine tuning. So, yeah, if we have numerous stations which are fairly close together, we can improve that resolution. And I know the city of Calgary has quite a number of them, as you mentioned, Ross. But yeah, I know there's quite a few in Canada, and we've kind of taken a look at a lot of those. But where a lot of the value um, that is provided to our customers is that they might have weather data that's not publicly available. So that's kind of an extra value add.
Very cool. Any other questions? I don't see anything else that was dropped in chat there. If anyone wants to anonymously put them in, kind of the chance there, and I'll kind of do this as the last call before we get into the casual chat time. Not seeing any hands up or anything else in chat there. All right. Thank you so much, Craig. Really
Yeah.
appreciate you providing all of your insights. And it's really cool to see the generative AI being used for things beyond just art and text information. I love AI in terms of it's more than just what we kind of think for our usual going on to GPT or Microsoft Copilot. There's all these other areas where it's really embedding itself into industry and innovative ideas and really providing these great use cases and benefits to major companies that don't necessarily hit the everyday, but potentially in the future will be able to create more accurate forecasts and information potentially for everyone who's maybe planning their trip to work or planning their vacation or different pieces like that. Um, Anything before we close off the recording for those online listening in?
Thanks everyone for coming and attending, and I really enjoyed presenting Erode AI to all of you. And if anyone is interested in learning more, coming up out to Innovation Week in a few weeks, come by and stop by the stall. I should be there on the Wednesday. I think is the 21st or 22nd. So yeah, thanks again everyone for attending the talk.
Yeah, thank you everybody. And yeah, Innovation Week is just starting up. I think the launch night is tomorrow night. So if you want to take a look at that, if you look up Calgary Innovation Week on Google, it should go to the main website there. There's a whole list of different events and pieces going on. I think that's still being populated. I'm going to be taking part in a couple of them myself. The Megatech group that we're a part of has an event that's happening on Monday the 18th. So I'll be there that evening with some of our colleagues there. Thank you to those who were able to attend online. Really appreciate the questions. And thank you to those listening in on the recording. Always appreciate those views on YouTube. Make sure to subscribe if you are watching to be able to get those updates for our videos. And I hope everybody has a good evening here in Calgary. And if you're watching this online, a good whatever rest of the day time that you're watching the recording on.